Lee Benfield. As you see, I work at the Quantitative Analytics Group at Bock Capital. And, well, kind of giving the game away here, but I'd just like to talk about... which one am I? Okay, so, well, the game's kind of given away here, but I'd just like to introduce you to one of the most popular software development tools in the financial industry, in investment banking, and probably in the world. Like Aaron said, if you go onto a trading floor in an investment bank, the screen that you see that hasn't got a copy of Excel running is the weird one. They've all got it running. Here it is, you know it, you love it, or you probably loathe it. So, why do people use it? Why do people love it? Well, there's a couple of reasons. Some of these are good, some of these are bad. Visibility. You get to see everything on a spreadsheet. The data you're dealing with is totally laid out in front of you. All the intermediate values in a calculation are laid out in front of you. It's like having, like, the debugger is there. Immediacy. You change one number, and you can manually go and calculate all the dependencies of it, or you can just say, give me all the dependencies, and you can see what's going on. Flexibility. Unless you've used Excel probably in the financial industry, you don't know what kind of extremely disgusting things you can do with it. But you really can use Excel to do all sorts of things. I've seen Excel used as a job control application. I'm not joking. You can do anything with it. And control, but actually the bad kind of control, in as much as the people who sort of sit there and monitor it and make sure you're doing the right thing probably don't like Excel so much. A lot of places have projects to get rid of Excel, which get started every 6 months, and at the end of the 6 months they go away and come back in another 6 months. The kind of control I'm talking about is the kind of control that the guys on the desk want, the traders, because a good trader is a bit of a control freak, and he gets to do whatever he wants. So, what's really missing from Excel? Well, object support is the really, really obvious one. A lot of people, it's like the first thing you do when you start working with Excel. You just sort of retrofit object support to it. It's quite easy. I'll show you later. And library functions. Obviously, Excel has some extensibility features for adding functionality with DLLs that you can write in C, or by writing custom functions in VBA. Except it's never quite that simple. We can't just use our quant library directly from Excel by, sort of providing it as a DLL. The reason for that is, certainly where I am, the quant library, it's a little low level. It provides lots of useful objects for doing modeling, but they need to be glued together. So what you usually end up is, with the quant library sitting at the bottom of the stack, the spreadsheet sitting at the top of the stack, and somewhere in the middle there's a little bit of glue which someone has put together in, yep, you guessed it, VBA, which is, yeah, I heard a wince there, thank you. Now, VBA, yeah, it's used as glue inside a sheet around these lower level libraries. It's used heavily to overcome just silly little weaknesses that you can't do in Excel, like functions, looping, interacting with object libraries that someone hasn't provided you with a nice little Excel interface for it. Now, the really horrible thing here is that you end up with a mishmash of calculation models. We've got this one here. We've got this guy on the left, which is the DAG. It's the graph of the spreadsheet, which is one calculation model. And then we've got the guy on the right, which is VBA. And these two really are kind of orthogonal calculation models. They interact, usually badly, but they interact, and it can get quite ugly. And some other issues. Why does this cause problems? Well, there's always going to be fun developing pricing sheets like this. As I said, little stack, quant library at the bottom, Excel at the top, and some VBA wrapper in the middle. Now, the VBA wrapper is usually, in our case, maintained by some IT team that isn't really part of the quant team, so that any new functionality that you get put in, I'll get to the point soon, any new functionality that you put in, has to be propagated manually up this tree, and this takes time. The time to market is obviously going to be vital if you're introducing new functionality. Then there's a really icky one, which is, I've got a desktop, I'm a trader, I want to price something, I want to see it price. But I also want to run this on a blade farm. So what I've got to do is I've got to take these two orthogonal calculation models and dump them somehow onto a blade farm. The most disgusting version of this I've seen is actually someone launching Excel processes on a blade farm, which, yeah, it's not nice. One other really horrible thing is that you can quite easily make VBA functions side-effecting. It's all too easy for some guy sitting there writing some VBA to just manipulate a little bit of global state, and then you end up with a problem because Excel's calculation tree doesn't really have a total ordering. So you end up with a situation where it might calculate one part of the graph first or another part of the graph first. And so you end up with a little button that says calculate the spreadsheet in the right order so that all the side effects happen in the right order, otherwise I'll blow up. Which is just horrible. So, going back to my little sort of two orthogonal development environments, if we drop VBA completely, we've got a zeroth order functional environment, which something Simon said in one of his papers at one point. And we need to drop into VBA when we can't represent what we need to do, which unfortunately, as I said, looping functions, etc., is quite a lot of the time. What we want to do, we've got some really talented guys who are very, very familiar with Excel, but they need to deal with VBA, unfortunately. What we want to do is we want to keep the expressiveness and power of the call graphing environment in Excel. We want to let these traders leverage the expertise they've already built up with this, but try to ameliorate or banish completely, if we can, the problems of dropping into VBA. So, what can we do? Well, I've just replaced in this little graph, just replaced Excel with FMD, which is a kind of retrofitted name for the project that I'm talking about here. Now, this effectively sits between our quant library and Excel and a bunch of other libraries, ComServers, .NET, .NET assemblies, and generates on the fly all of the boilerplate to let Excel talk to them. So this means that we can call our primitives in our quant library directly from Excel, and as soon as we add a new feature to the quant library, it's visible directly on the spreadsheet. And this doesn't buy us anything massive because we could have just written this in VBA, but it helps later on by generating the boilerplate. The boilerplate obviously can contain useful things like object support. So, well, here you can just see that's, switch to 2007 because it gives you a nicer picture. But so I've generated all the functions on the fly. Generate some object support. These little @@ symbols. Everyone who writes their own object layer has a little slightly different way of doing objects. But basically, the little @ things you see there are object handles, which you can do whatever with. Here I've got a volatility surface in a cell, and I'm just looking at it because it's nice to render pretty things. And other than a tiny little bit of VBA, which does the menus, you haven't got any VBA on this spreadsheet. It isn't particularly exciting, but it gets us started. Right. So, because we're generating all of the boilerplate, we can be a little more ambitious about what we're actually doing in this boilerplate. I've got a really daft example here, in as much as this function is actually built into Excel. So, what I'm doing here is I'm using 3 function calls from our quant library. I'm creating a date object using the date create from serial function. I'm getting the day of the week from it, from that date object, and I'm converting that to a string. So I've just got 3 chained function calls. And that's it, really. Now, I don't actually know if this is the official name, but there's a very common pattern that anyone that uses Excel a lot will come across, which is just a copy down. Effectively, what I'm saying is, okay, so I've done this. Now I want to do it for a bunch of different input values. So the copy down effectively is just it's a development pattern, if you can use that word, whereby you effectively just copy the steps across in a single row, and then you can just drop it down and achieve the same thing. Hopefully that's made a couple of people in the audience shudder slightly. So, what can we do to make this more interesting? So, what I've done is I've introduced a couple of new functions into Excel and introduced features in the auto-generated boilerplate that play nicely with them. So I've introduced a function. I've got the text for the function above it. So what I've done is I've replaced my input date with a function called variable of date, and this introduces a named variable called date. If I now evaluate date create from serial, where previously I would generate a date object, what I end up generating instead is a function which requires an input date and gives me back a date object. Again, if I call date get day of week on that, it takes a date object. This is just pseudocode, it's nothing real. It takes a date object and gives me back that. And again, finally, if I do date convert day of week to string on that, it gives me a function which, chains all of the relevant things. I haven't done anything to my original spreadsheet other than change the word, the original input date to be a single function called to my variable add-in function. So what I can do now is I can introduce an evaluation function, which effectively allows me to say, okay, I've built a function, now I'd like to evaluate it with a particular date as an input. So what I can do now is I can just effectively drop all of the repeated calculation steps in this spreadsheet. Obviously, I'm still doing a copy down here because I'm just copying down the evaluation. But there was a lot of redundant logic in the spreadsheet before, which I've got rid of completely. You can probably guess where this is going next. You can map over it, obviously. All I'm doing here is I'm taking some very, very simple patterns from functional programming, and I'm applying them to Excel, which really, really needs them. So you can map over these guys. As I said, I extended Excel to allow objects to be represented in cells. This is vital for representing anonymous tabular data. So here, obviously, I get such a safe array, which means you can see that I'm using com somewhere in it. You can see that as a result of calling this map over this, I've got an array of all of the correct answers. And this is nice because it means that other than my input data, which I can move somewhere else, I'm no longer restricted to the topography of the sheet. I can just, I can throw it away in effect. A couple of examples which I'll kind of run over quite quickly because I'm running a bit late. The code, you don't write the code, the intermediate boilerplate writes the code for you, which means that if you want to map over multiple values, you might want to, so what this will do is it will introduce a function which sits over your original function but takes 2 tuple instead of the 2 arguments your original function took, and then it will pass your original function a list of 2 tuples instead, which allows me to do something like that. Quite nice. It's designed to make it so that the people who are using it don't need to worry about doing all the silly little things like that. There's sometimes you need a little help for ambiguity. So if I'm taking a function which requires A and B, and I'm naming the arguments when I map over it, because I'm not writing the code, I need to be able to give the user a nice, easy way of specifying what argument they want things to apply to. So if I'm mapping over these values of A, there's 2 pseudocode again here, but there's 2 legitimate things I might want to do. I might want to create, on the left here, I create a list of functions, and on the right here, I create a function which just, when it's given a B, effectively flips the original function and then maps over it. These are 2 entirely legitimate things which I can do, and it just provides the user with a way of choosing which one they want to do by giving a 4th argument to my little map function there to say, which one do you really want to do? I'd like to switch to an almost real example. Yeah, it's lovely, isn't it? So what I've got here is just a calculation tree which calculates a fairly simple option. It's pretty gross too. But, so if we consider, I've built this calculation tree which prices this option, and out of the bottom comes a number. So now I want to price this for a different thing. What I want to do is I want to price a spot ladder. A spot ladder just means, give 30 values of the spot input. If you can see, all of the little blue cells are just inputs into these things. The handles here are objects, such as the accreting rate, the repo rate, discount rate, etc. So to price a spot ladder, at this point, normally you'd have 2 choices. You could either turn around to the IT guy and say, I'd like you to transliterate this into VBA for me, please, and give me a function, at which point you feel very sad. Or you can take this and rearrange it so it's a copy down, at which point, well, you lose a lot of, believe it or not, that actually looks a bit cleaner than copy down might. You lose a lot of the clarity, and it's a mess, and you have to do work for no reason whatsoever. Why would you want to rearrange this when you've just written it and you're happy with it? So what I can do, fairly obviously, is I can just say, I've changed spot to be a variable, pressed F9 to calculate it, and the fact that this, this function is a variable of spot, anywhere that depends on my input variable spot, this is propagated down to my final result, which is now a function of spot. And I can do my spot ladder simply by mapping this over my input values of spot. Obviously, you might want to do this for multiple things, so I've just changed volatility to be a variable instead. So now my function is a function of spot and volatility. Now, I can, like I did earlier, I can map over multiple values at once. So here I'm kind of doing a spot vol ladder. Or I could say, take this function and map it over these values of spot, and then take the result of that and map it over these values of volatility, and I've produced a spot vol matrix. Now, to do this without this sort of trickery, to produce a spot vol matrix, you would really need to send it off to some IT team and get them to rewrite it in VBA, at which point you're using VBA and you feel ill. So, just some final words. If you think about this, what I'm doing here means that I'm not really using Excel. I've kind of got some people who are very, very happy with Excel, and I've tricked them into writing some code, which means, of course, that I can take that code and I can just execute it on the command line, or I can take that code and I can load it into a completely different spreadsheet and then price exactly the same thing. So here I'm just pricing my original thing, 13.57, and my answer is, again, 13.57 both times. Who's using it for what? It was originally designed just for like 3 or 4 people to use, but a lot of people found it quite useful, and it's being used by about 250 internal clients at the moment. It's being used across all sorts of asset classes. We quite like it because it cuts model development massively. You've seen that you can run something on the command line. This means that a quant who builds a model can just throw it onto a back end, and the same model exactly will get priced on the back end, on the blade farm. This means, the last model we released on this, it took, it took under a day to get this on the back end, whereas previously it would take a couple of months because you'd have to transliterate it and then back test the transliteration. It's being used for ad hoc reporting tools. There's no particular reason why you need to do models like I showed. You can obviously just pass around functions as objects themselves, so you can use higher order functionality, which means that our risk managers are effectively able to just say, I want an arbitrary defamation of certain types of market data parameters, which means that they can get completely ad hoc risk reporting, which is very cool. They just couldn't do it before. And I think I've kind of run out of time. So okay. Some implementation observations. Memorization. Excel, if you think about it, every node on a spreadsheet, every cell on a spreadsheet is effectively cached because Excel is using it. So if we have a diamond, then something isn't being calculated twice. If you abstract away that, you end up with a function which you'll need to memorize that function appropriately. Typing is icky because Excel really it has 3 types, but effectively everything is just an Excel opera. So this is not a strongly typed language. Before anyone asks, the interpreter is actually written in C++ because it just fits better in with Excel. I have a post-extraction phase compiler which translates into F# and then compiles that. If you have non-pure functions in scraped libraries, then you're going to end up with these side-effecting problems I was talking about earlier. And what I've got layers which actually take impure functions and either ban them or transform them until they're pure by taking say a non-const method on an object and translating that into a clone and then modify. Obviously, there's extra cost associated with that. And as I said, I've used a custom engine because there are some interesting issues to do with the fact that every cell on a single spreadsheet thinks it is the final node when it's being calculated, and you really don't want to have to call out to a third-party compiler every time you press F9 300 times, or actually some of these have 10,000 cells on them, so you just want to avoid that. And that's me.
On the examples, you often had add and then a scary number.
Yeah.
What was that?
That was, as I said before, that was effectively an object handle, because one of the serious weaknesses that Excel has is it has no way of representing objects.
Okay.
So everybody solves this in a slightly different way, but what I've done is my boilerplate layer, effectively, if it sees that an object is trying to be returned back to the spreadsheet, it takes this, it translates it into a string which starts with @, and then on the way back down, it translates it back into an object.
So what happens if the Excel user uses an Excel primitive to add two numbers, say?
Yeah, absolutely. This is a real pain because Excel doesn't support overloading of its primitive functions. However, I have a simple routine which will go through a spreadsheet and replace Excel primitive functions with functions which I can generate the boilerplate for.
You mentioned earlier that for impure functions you try to translate them by doing a clone on any argument objects, presumably.
Yeah.
How can you be sure that's a deep clone?
In most of the cases with our quant library, I can be sure it's a deep clone because I get promised that it's a deep clone. We've had some issues where people have promised it's a deep clone and lied. It doesn't necessarily have to be a deep clone. It can be as deep as is required, obviously. But yeah, if people make promises about purity of functions and then lie, then
Okay, so why allow impure functions?
because unfortunately our quant library was not originally developed with a strong functional bias. So a lot of the really useful functions in the quant library, which such as add one to a date, yeah, you want to keep that guy.
You should press the button.
Are you able to author new functions in the language that right in the Excel session?
Okay, you're able to generate functions which you can then call back to evaluate. You're not able to author new functions by publishing them into, I guess what you mean is, can I publish this into the Excel namespace so I can name this, yeah? Yeah. Okay. You can't do that. The reason you can't do that is because if I had two disconnected graphs, one of which generated a function called Fred and one of which used it, if I then changed the definition of the function called Fred and calculated my spreadsheet, Excel has no reason to evaluate the one separate graph which defines Fred before it evaluates the one that uses it. So in all of this, I'm relying on the call graph to force the right thing to happen. And this is a problem of this lack of total ordering that I was talking about earlier.
But you did say that you often traversed the call graph yourself. Why would you depend on Excel to do that for you?
Sorry, I may have not made myself clear when I said I traversed the call graph myself. What I do is, when I press F9, Excel traverses the call graph for me, and then that causes these functions to be generated by the boilerplate. I don't ever explicitly traverse the call graph myself.
Thank you.
So, breaking the normal structure of this, I actually have a question for Simon, which is, I've now heard this talk several times, more or less, not the specific talk, but this general talk of like, here we are at a financial firm, coping with the fact that Excel is good but not actually good enough and is missing functional ideas. And I imagine you've probably met some of the people who work on Excel, and I'm curious what they think about this and whether they view this as a problem that they would like to solve.
So indeed, I have had this conversation many times with the people who build Excel. Excel is like a super tanker. It has a lot of mass and very high value, but a fairly small crew. Right? There's kind of 3 of them sitting there at the back of this megaton thing. And there are a lot of people whispering in their ears. And much as we would like to believe it, unfortunately, while banks are a very important customer of Excel, they're not the largest numerically. So they recognize this problem. They have seen people with @ signs in their spreadsheets a lot and thought that'd be nice to fix. But somehow, Google has collaborative spreadsheets now, so we'd better have them too, and stuff like that happens. There's an awful lot of other things that they have to do. So I've tried very hard, but they have a lot of calls on their time. That's the best I can say. But it's not that they're stupid or that they're ignorant of the problem. It's just that they have a lot of other things to worry about too. What can I say? I wish they'd do it. It'd be so much better.
It'd be cool. I could do something else.
So I was a bit surprised by one thing in your design, which is you build up these vectors or matrices, and then they live in a single square.
Yeah.
So sometimes, indeed, you do want a structure to live in a single square.
Yeah.
But, of course, the beauty of Excel is that it's dealing with all these lists and displaying them for you.
Yeah.
So did you think of having something that would take one of your bits, one of your objects, that is an array or a vector, and pasting it back as an array or a
You
vector?
absolutely can do that. I've provided array formulae to do this. I've actually got this, all the kit with me, so if you want a demo afterwards, I'd be quite happy to.
Another question. You had those nice blue arrows.
Yeah.
And did you generate them automatically with your tools and analyzing?
No, that's the audit tool in Excel.
Sorry, what?
That's the formula audit tool in Excel.
Oh, it's
which
in
will show you
Excel
the
already?
dependencies.
Okay. Okay.
All right. So, yeah, so thanks, speaker.